Welcome to my kcse revision channel. Teacher James Marita, the Boys High School. Kindly subscribe my channel. Click the notification bell such that you get notified once I upload a new video. Today we are looking at mathematics, volume of solids. Volume of solids are topic in Form 2. So in KCSE 2008, there was a question of 10 marks that was dealing with the volume of a conic, volume of a cone, and also the volume of a sphere. So in this case, you need to know the various volume formulas of getting the volume of the solid. You understand the formula of getting the, the, the volume of a cylinder, the volume of a cone, and also the volume of a sphere. So this question was testing the two things. It was testing the volume of a sphere and also the volume of a cone. So the question reads that the diagram below represents a conical facet which stands vertically. The facet contains water depth of 30 centimeters. So this facet, this diagram is in the form of a cone. So it stands here vertically. It contains water up to the height of 30 centimeters, as you can see. And then the radius of water in the facet is 21 centimeters. So we have this radius of this water here. The water level has a radius of 21 centimeters. So in this case, the guideline here, if we are taking pi to be 22/7, if not guided, you can take 22/7, on this case 3.14. So what are we supposed to do in this question? We are supposed to calculate the volume of water in the facet. The volume of water in the facet, water has a height of 30 centimeters and it has a radius of 21 centimeters. So we are supposed to calculate the volume of water in this facet. Then, when a metal sphere, in this case, a metal sphere is completely submerged in water, the level of water in the facet raises by 6 centimeters. So in that case, we are supposed to calculate the radius of the water surface in the facet, in that case, and then also you find the volume of that sphere which has been submerged in that facet, and then finally you find the radius of the sphere. So here you are supposed to understand two things: how to calculate the volume of a cone, because this facet it is in the form of a cone, and also how to find the volume of a sphere. So the question was testing on the two things. So to start with the first one, we are supposed to calculate the volume of water in the facet. This one is very easier because we have the height of water here. The height of water here as 30 centimeters, and then the radius of water of the water surface. The radius of this water is 21 centimeters. So how do you calculate the volume of water in this facet? So to get the volume of water in this facet here, the volume of a cone is normally given by is 1/3. Then we have pi radius square, and then we have h. That is how you can find the volume of a sphere. So applying this one, we have our pi is given us 22/7, and the radius of 5, the radius of 21 centimeters, and the height of 30 centimeters. The volume of water in that facet now will be equivalent to, it is 1/3. Our pi, as instructed there, is 22/7 multiplied by the radius squared. So in that case, the radius is 21. You square this one also, we can have 21. And then you have the height of this water, as in this case, 30 centimeters. So if you work out that one, you will get 13,860. So the volume of this one is giving us 13, then we have 860, in this case, centimeter cubed. We have not been guided whether we are giving the answer in the number of significant figures or the number of decimal places. So the volume of water in the facet is equivalent to 13,860 860 cubic centimeters. Then, when a mesosphere is now submerged, we have this a mesosphere which has been now submerged in this fashion. The level of water rises by 6 centimeters. So what you can see from here that the level of water initially was 30 centimeters. If the sphere, a metal sphere is submerged, the level of water rises by 6 centimeters. So we are going to have the new height of water. The new height of water now will be, let's say that it will be somewhere here. We have the new level of water, the new height of water now, the water will be raised by 6 centimeters, and then we have that new level of water up to there. Such that now this is by 6, the water rises by 6 centimeters, then the new level of water will be, so this one will be, in this case, you will have 36 centimeters. So the height of that new height of water will be 36 centimeters. So because if the mesosphere will be submerged in that case, the water rose by 6 centimeters, it means that the new height of water will be 36 centimeters because initially it was 30 centimeters. So after water rose by 6 centimeters, then we are supposed to calculate now the radius of the new water surface in the facade. So how do you get the radius of the new water surface in the facade here? So you can say that let's say that the new radius here be r. So you say that let the radius, we say that let this radius be, in this case, r, that case. So using the ratios in that case, that is the similarity and the enlargement, we can have now this as the large radius, which is r, all over the smaller radius. The smaller radius in this case here is 21 centimeters, this one here. So we have this one as 21 centimeters, is equivalent to the height, the larger height, which is in this case 36 centimeters. So you have this one as 36 centimeters, all over the smaller height, in this case, which is 30 centimeters. In that case, you need to understand the concept of similarity and enlargement for you to score well in this question. So from here, you can cross multiplication, and we cross multiplication on this one here. We have now 21 times 30, so it is 21 multiplied by, in this case, 36, and this one will be equivalent to be 30 times r, which is giving us that. So to get that, the radius is equivalent to b. We have this as 21 multiplied by 36 in that case. Then you divide it by, this one is divided by 30, and that the radius will give us 25.2 centimeters. So we have this is 25.2 in that case centimeters. We have not been told to, we have not been guided whether we are giving the answer in the correct 2 decimal places or to the number of significant figures. Where there is no guideline, it is good that we have to give your answer correct to 1 decimal place. So what do you need to understand here? They understand that there is similarity and enlargement, whereby now you talk of the radius of the large radius, whereby now when the mesosphere was submerged, the level of water rose by 6, and the new height of water is equivalent to that 6 centimeters. So we don't know that radius, so you let that radius to be r. Then we have our smaller radius will be 21 centimeters. So that's why we have now let the radius to be r. Using the concept of similarity and enlargement, we have now r all over 21 should be equivalent to be 36 all over 30. Then you solve for r. R is equivalent to 25.2 centimeters. Next, we are supposed to calculate the volume of the mesosphere in centimeters. So how do you get the volume of this sphere? There are 2 things you need to understand. There is the volume of water initially, This volume of water here, which was 13,860, represents the volume of the smaller cone, because this one here it represents the volume of the smaller cone. Then we have the other volume, the new level of water. The new level of water is up to 36 centimeters. So if we take the new level of water to be 36 centimeters, then we are going to have two figures here, two solids here. We have the smaller cone, which is represented by water, of a height of 10 centimeters and a radius of 21 centimeters. And then we have another large cone, which has a radius of 25.2 centimeters and a height of 36 centimeters. To get the volume of water, the volume of a sphere, it is the volume of water displaced. So we start by first getting the volume of the large cone in that case. Our volume of this large cone, we are using the 36 centimeters and the radius of 25.2 centimeters. So the volume in that case is equivalent to P. It is a third, as you can see, times pi. Our pi is 22 all over 7 times the radius. The radius, now we are talking of this new radius here because it represents the radius of the larger part. So this one will be 25. So you have this as 25.2, and if you square that one, will give us 25.2. You multiply it by the new height of water. The new height of water in that case is equivalent to the 36. So you get the volume of the large cone. And if you work out that one, it will give you an answer of 23,950. So we have this is 23,952 points. So we are point in this case 0.8, in that case centimeter square. So that one gives us the volume of the larger cone. Then there was initially a volume of the smaller cone, which was represented by the volume of water. That one was equivalent to 13,860. To get now the volume of the sphere, it is the difference of the two volumes. You subtract 20. You take the new volume, which is 23,950.08. You subtract 13,860, and that one now will give you the volume of that sphere. So in that case now, to get the volume of that sphere, volume of sphere in that case, the volume of that metal sphere is now equivalent to, you get that one is equivalent to the 23,950.08. This one you subtract 1,300, in this case 860, and that one will give us the volume of a sphere as 100. Volume of a sphere as 100. In that case, 100.90.08. In that case, we have cubic centimeters. This is the volume of a sphere. So you can also use the ratios. If you can use the ratios here, an alternative way of getting this one, you can use the ratio, whereby first of all you will have you can use the ratio here, whereby you will have first of all that you get the linear scale factor. The linear scale factor, which will be equivalent to the linear scale factor. In that case, you will have, this is a linear scale factor. You have, this is 30. You divide it by, in that case, 36. This one is giving us 5 all over, in that case 6. Then also you get the volume, in that case scale factor. This one is, now you take, this is 5 all over 6 volume scale factor. You cube that one, and that one will give us 125 all over, in this case 216. Then this 125, it is representing 125. This 125 represents the volume of a smaller part. So you say this 125. This one represents the volume of equivalent to 30,860. What about now the volume? What about 216? 216, which is representing the volume of the larger part. So if you work out that one, it will also lead you here, whereby it will give you the volume of the larger cone, which is equivalent to 23,950.08, and then you should find the difference to give you the volume of a sphere. Then the last part, we are supposed to calculate the radius of a sphere. So to get the radius of a sphere, now that we have the volume of this sphere, we have the volume of a sphere. We know that volume of a sphere is given by 4 all over 3, then we have pi radius cubed. That is the volume of a sphere. But we know that the volume is equivalent to 10090.80 in that case, cubic centimeters. So where there is this volume, you substitute that. So we have 4 all over 3, then we have pi r cubed. This one should be equivalent to that volume, and the volume is equivalent to be 100, then we have 0.08 cubic centimeters. So from there you work out for that, multiply both sides by 3. So we have this is 4 pi r cubed, which is equivalent to be 0090.80. This one is multiplied by 3. To get now the radius here, so you have the radius cubed is equivalent to be, this is 10090.08. You multiply this one by 3, then you divide by 4, in this case 4 pi. So if you are dividing by 4 pi, so you have this is 10090.80 times 3 times now 7. In that case, if you replace this pi by 22/7, then you divide by 4 multiplied by 22. And if you work out that one, it will give us a radius which is equivalent to 13.40. So our radius, of course, now you are supposed to find the cube root. So the radius of this one, you find the cube root of that. A cube root of 10090.08. This one times 3 times 7. Then you divide under the cube root 4, in this case times 22. And if you work out that one, it will give you a radius which is equivalent to 13.40 in that case centimeters. That is the volume. That is the radius of that sphere. So to get the radius of a sphere, already we have the volume of a sphere, and then you use this volume formula by saying that the radius of a sphere is equivalent to P4/3 pi r cubed. Then you substitute where there is volume, because initially we had the volume of that sphere as 10090.08, and that one now will give us the radius of that sphere, which is equivalent to the 13.40. Don't forget to subscribe my channel, watch and share. Thank you.